Here is a wonderful video on calculus. You'll appreciate the integrated approach which we follow with our students. I am Anil Kumar. Welcome to my YouTube channel. It's absolutely free for the last 15 years, a learning platform where you post problems and we provide you with solutions. In this video, we are going to discuss a function which is given to us as x times square root of 1 minus x squared within the domain minus 1 to plus 1. We are going to discuss the following parameters about this function. Whether it is even or odd function, find domain and range, find maximum minimum values, graph the function area within the curve and the x-axis, transformation of the function, volume of the solid by rotation, and volume after transformation. Now, that is all what you study in any calculus course at school level. So, we'll discuss these points taking a very interesting function so that all your concepts are absolutely clear. To keep the videos short, I'm going to release a series of videos providing their solutions one by one. Follow us on YouTube, learn more, and you can also send an email on globalmathinstitute at gmail.com to learn more from me directly. Great. So let's begin with the basic concepts and then move on to derivatives and find maximum and minimum in this particular video. So we are given a function which is f of x equals to x times within square root 1 minus x squared. Is it an even function or an odd function? To test this out, we need to find what is f of minus x. That's it, right? So f of minus x should be replace x with minus x, correct? That's the whole idea. So we'll provide you with step-by-step solutions so that you understand what's going on here, right? So this is part of a pre-calculus which you should know. So when we do this, we have minus of x here, square root of 1 minus. Square of anything is positive. So there you go. And so we get 1 minus x squared. Now definitely this is negative of f of x. Now, since we know that f of minus x is equal to negative of f of x, we can say that f of x is an odd function. Makes sense, correct? First step. Odd function means what? Odd function means it is symmetric about the origin, okay? Correct. Now let's move on to the next topic, which is how do we find domain and range? So once again, let's take this function f of x equals to x times square root of 1 minus x squared. Now x, this part has no restrictions. Domain could be all real numbers, but the part within the radical has a restriction. So the first part x has no restriction, but the part within radical 1 minus x squared will have restriction, and that will help us to find the domain of the function. I know we are given this since we just started with a genuine good problem. So, but we should know how to find domain also. That's the whole idea. That's what we mean when we say integrated approach to calculus. So this is one of our pages from our integrated approach. We have many functions which we discuss in this way with our students. So So what is the key parameter? 1 minus x square should be greater than equal to 0. So this is the inequality we need to solve to find the domain of the function. So let's now solve this. So we get 1 is, or let's say minus, or what should I say? Let me say 1 is greater than equal to x squared. Let's take minus x squared to the other side. So 1 is greater than this. Since it is x squared, we'll do square root on both sides. Now, same operation on both sides should not make any difference. And therefore, we can now write it like this. Square root of 1 is greater than equal to square root of x squared. Clear? Now, at this point, many of you will think what? You will write this as 1 greater than equal to x. Means x is less than 1, right? Clearly, that is not what is being shown here, right? Do you see that? X is within minus 1 and plus 1. That means you've done a mistake. You get the whole idea. You should watch my videos on what is square root of x squared. Square root of x squared is not x. It is absolute value of x. Makes sense. So we are saying this square root of x squared is, which you should know, is absolute value of x, not x. Or in a different way, absolute value of x is less than equal to 1. Now that gives you the domain of the function, which is written there, which is x is within plus and minus 1. Makes sense? Correct? So on a number line, if you have to show this, why are we doing so? Because calculus requires all this, right? So we are within this interval, which is from minus 1 to 1 on a number line. You get the whole idea. So that is the domain of our function. Now, second part to this is, what is the range of the function? Well, to find the range, I need to find maximum and minimum for this function, right? We know it is restricted within this particular domain, and we also know it is continuous within this domain, right? So there are no discontinuities. We also know the zeros of this function, right? But now let's focus more on maximum minimum. To find maximum and minimum of the function, we need to find the derivatives, correct? So the function given to us is x times square root of 1 minus x square. So let's find the derivative. So to find the derivative, we are going to use the product rule. Derivative of x is 1. So we are using product rule. So we say that derivative of x is 1. So it is 1 time the function, which is 1 minus x square, the other part, plus x times the derivative of 1 minus x square, which is 1 over 2 square root of 1 minus x square, times the derivative of inside function, which is minus 2x. Makes sense, correct? So we got an expression for the derivative. This we can definitely write as square root of 1 minus x square, right? Now, 2 and 2 cancel, so we can write minus x square over square root of 1 minus x square. Now, we can take 1 minus x square as common denominator. And here, when we multiply, we get 1 minus x square. Let me write like this, times 1 minus x square minus x square. Clear? Now, here also we have square root of x square. Now, this square root of x square, if it is positive, the absolute value is same as x, right? And therefore, you could rewrite this as 1 minus x square minus x square. Clear? Over square root of 1 minus x square. Combining the terms, we get 1 minus 2x square over square root of 1 minus x square. Correct. So we get the derivative of the function, which is 1 minus 2x square over square root of 1 minus x square. Now, to find maximum or minimum, we need to find the critical numbers. Critical numbers are where the derivative is either 0 or does not exist. And the function should be continuous, right? Which it is. Okay, great. So the condition is that in this case, the derivative should be equal to 0. And that really means that 1 minus 2 x square over square root of 1 minus x square should be equal to 0. So this helps us to find the critical numbers. Since it is 0, the numerator should be 0, right? So let's put numerator to 0. And that means that 1 minus 2x square equals to 0. Now we can solve this, right? So when you solve this, x square should be equal to what? 1 over square root 2, right? So let's solve this. So we get 2x square equals to 1, or we get x square equals to half, and that gives you the solution that x is equal to plus or minus 1 over square root 2. Makes sense, correct? So x has to be plus or minus 1 over square root 2. Now, at one of the points it could be maximum, at other point it could be minimum. So we need to really test it out, correct? So let's take this derivative on a fresh page. We at least know the critical number, and we are going to make a table to text out whether it is a maximum or a minimum. Is that clear, right? Okay, let's move on. So we have this function f of x, which is x times square root of 1 minus x square. And we also now know the derivative, which is, I know square root of 1 minus x square was in the denominator, and in the numerator we had 1 minus 2x square. And we know that the critical number, which basically is when the derivative equals to 0, is that x equals to plus or minus 1 over square root 2. Well, some of you could rationalize and write down this as plus or minus square root 2 over 2. Correct, no problems. I'll keep it like this for now. Great. So we have two critical numbers. One is plus minus, one is 1 over square root 2 minus, one is 1 over square root 2 plus. Let's analyze this to figure out where is our minimum, where is the maximum. So we'll make a table to analyze this. Great. So we'll put the values of 1 over square root 2 negative, 1 over square root 2 positive. And we are going to take test points. Well, the other limit is minus 1 and plus 1. That's the domain of the function. So close to minus 1, we can take a point 0.9 negative. Here 0.9 positive. In between, we could take 0. To analyze the function, we have two parts to this. One, the numerator. Numerator is 1 minus 2x square. Denominator is square root of 1 minus x square. Now, denominator is always positive, right? Correct. So, denominator is always positive, so without thinking much. Now, if I put minus 0.9 in the numerator, which is 1 minus 2x square, then it is going to be a negative quantity. With 0, it is going to be positive, and this will be negative. That means the function, in this particular case, if that's the case, the derivative is what? So now, when we divide the numerator by denominator, negative with positive, we know the derivative will be negative. In this case, positive, and then negative again. That clearly indicates that the, the function will be decreasing, right? So the function will be what? Derivative negative means the function is decreasing, positive means it is increasing, and then again it decreases. So clearly, we have a minimum, right? And we have a maximum, correct? So minimum occurs at minus 1 over square root 2, and maximum occurs at plus 1 over square root 2, right? So we know the x values, minimum and maximum. Great. Let's go to the next page and find the y values also. So for the function f of x, which is given to us as x square root 1 minus x squared, we found that the minimum is when x equals to minus 1 over square root 2, and maximum when x equals to plus 1 over square root 2. So we can substitute this value and find the value, y value, okay. When x is minus half, so we get minus 1 over square root 2. Square root of 1 minus 1 over square root 2 whole square. And that is minus 1 over square root 2. And this gives you square root of. So this is 1 minus half, right? So 1 minus half is 1 over 2 only. And that gives you minus half. Now for the other, let's do x is half, 1 over square root 2 times 1 minus 1 over square root 2 whole square. So 1 minus half is half, right? So it is 1 over square root 2 times 1 over square root 2, which again is half but positive. So we now know that the maximum value, let's call that as q and p as the minimum. So we can say that the minimum, let's say minimum, right, p, is at minus 1 over square root 2. Y value is half, minus. And the maximum value is q, which is at 1 over square root 2, and the y value being half. Now, once you find maximum and minimum, you could actually answer the earlier question, which was on range, right? So let's go back to our question on range, which is right here. And now we can add what is the range, right? Okay, great. So now we find the range is between maximum and minimum values. So minimum being minus half and the maximum being plus half. Makes sense. So finding range was not a straightforward question. This is very important to understand. To figure out the maximum minimum, we have to go to calculus. And we went there and we found the derivative. Once you find the derivative, you have to find the critical numbers, which were at plus minus square root 1 over square root 2. And then you need to analyze them using table of values, which is very common practice. Those of you who have learned second derivative could also use second derivative test. And then analyzing, we figure out that the minimum occurs at minus 1 over square root 2, and the maximum occurs at plus 1 over square root 2. Maximum minimum values are minus half and plus half, as expected, since we know that the function is odd symmetry. Do you see how everything comes together? Odd symmetry means there will be a reflection of a point about the origin. So maximum minimum will be same distance away from the origin, which has been justified with these calculations. So I hope you understand the whole concept. In the next video, we'll take other parts of this, which basically is when we transform this function, how does the domain and range of the function changes, right? So that'll be one part. And then in another part, we'll focus on integration, where to find the area under the curve with the x axis, and also when you rotate the curve about the x axis 2 pi radians, one full circle, a solid can be formed. And that solid will have a volume. What is going to be the volume of this function? And also, if I use the transform function, by how many times that volume increases is of great importance to us. Once we understand these concepts, in that case, for any great exam like IBAP, high level mathematics exams, you are well set to get very good marks. You can always ace your test paper. That is where we come in. Global Math Institute. You can always contact us to learn more, practice with great questions, and excel. Thanks for your valuable time and all the best.